Hello there everyone, and welcome back for a bit more game dev. I've had pretty good luck lately, streaming pretty early in the day, so I'm gonna go give it another go today, because I'm looking at a piece of work that I think is quite sort of doable on stream. Let's hope so, at least. We are essentially continuing what we did last time. So last Friday I started working on a piece of heads-up display input prompt. Well, input prompts that are visible in the heads-up display. Let's get rid of the starting graphic there. And we can see what we're dealing with here. So I'm talking about these things here up in the top left corner. These sort of texts that are highly context sensitive, because first of all they are sensitive to the input mode that you have going, right? So depending on if you are playing with a mouse or keyboard, these things kind of switch from showing press F to switch vehicle here to showing press Y on the gamepad, that sort of thing. In addition to that, it also is sensitive to the kind of mode that you are in, right? So now we are in the cargo crane mode. You see a bunch of inputs up here in the top left corner, and these also switch between, you know, between the keyboard and mouse and gamepad. And finally, they also need to be sensitive to potential sort of input remappings in the future, right? You can't really remap anything currently in the game. It's all hard-coded for now, but the system is already there in place, so that as soon as I get a proper remapping menu going, you should be able to see your actual keys up here that you've set. So it's actually kind of a complex system, all things considered. And on Friday we got pretty far, but it turned out that my tech wasn't really perhaps capable of giving me the information that I needed to be able to draw this kind of menu. And when I mean tech, I specifically mean like the input system. So you need to be able to query the input system for a bunch of things to be able to draw a menu like this. And we can actually already see here that there's some complications going on here, because like this top input thingy here on the keyboard, it is 4 different keys, right? It's WASD. I can just move this crane around here with the WASD like this. On the gamepad, it's actually just one symbol that we want to show, which is this. Well, it keeps changing back and forth when I try to highlight it for you with the mouse. But it's just the left thumbstick, right? So it is like 1 symbol compared to 4 symbols. And how do we handle all of that? It's just a whole bunch of complexity that you need to be able to ask the input system. Hey, what does this actually sort of like map to, right? Do you have a separate render for your UI? I don't know what you mean exactly by separate. It is rendered using the renderer, but there's like a separate pass for it. It's not a separate renderer per se. It's just rendered using the normal renderer. Just some special shaders and that sort of stuff. I am using NanoVG though, like the NanoVG library to render the UI. So I guess that could be kind of maybe considered a separate renderer for it. But then it is actually, like, in the end it is rendered by the actual renderer. NanoVG is just kind of like producing you know, the actual shapes and shader information, if that makes sense. Anyway, so currently, since Friday, I've continued working on this a little bit, and I actually kind of I'm hoping to finish this work today, because for the next playtest, which is going to happen in December, I have a bunch of work still left to do on that, so I need to sort of like wrap this and move on to the next thing on my to-do list, right? I can't just spend all time on this UI stuff. So I'm hoping to actually kind of wrap this work today, at least getting into like a minimum viable product version. No doubt it will require some iteration anyway. Use NanoVG for the shapes and your main renderer renders the shapes. Essentially, yeah. Yeah, so NanoVG is... I can just quickly show you here. Right, like all of this is NanoVG. Everything you see here, even this video that's playing here in the background, which is you know, captured from the game, but it's a video. Even that is rendered by NanoVG. And this sort of stuff, this is all NanoVG. And so the way I do it is let's see if we can figure this out. Right, here's NanoVG. NanoVG is well, it says it right here. The project is not actively maintained. It's in a pretty good shape. So it's not like super lacking. It allows you to do kind of like basic, almost like HTML canvas-like things. It's modeled after the HTML5 canvas API. Not that I've really used that a whole lot, but I trust Mikko's word here. It comes with a OpenGL backend, which looks like this. It's basically just all in one file, right? And so this is just a bunch of like OpenGL calls. Let's see if we can actually find an actual OpenGL call. There's a GL delete textures. There's an actual OpenGL call. Create program, create shader, compile shader. So this is all just very much sort of OpenGL, geared towards OpenGL, right? I don't use OpenGL. So I have my own own sort of thing. NanoVG GFX API is the thing. Nowadays I use NVRHI. Maybe some of you have seen my NVRHI videos. So basically I just have a copy of that file that we looked at, which is the NanoVG OpenGL renderer. And instead I have some NVRHI calls. Like there's a graphics pipeline object, for example. Apply pipeline state. Then you just create your graphics pipeline object instead. So GFX API NVG create pipeline state. This is a function that is like it's not contained in the original OpenGL version, because OpenGL doesn't really have pipeline states in that sense. But you can see here we're filling out an NVRHI graphics pipeline description, and then at some point we're creating it right here from the NVRHI device. So yeah, there's a little bit of fiddling, but then the use of NanoVG is basically like standard. I have like a function or two that I've actually added to the library to make it a bit more suitable to my needs. But yeah, it's basically a NanoVG. Rightio. So we don't have these kind of lists for like a whole bunch of things. You can see that in the driver view here, when we're just driving around, we don't have any inputs there. If you switch to the cargo crane now has all of its inputs nicely laid out. The gravity crane also has them. It just doesn't have an extend or retract cable functionality, so that line kind of goes away there. But other than that, they're pretty much like sort of like done. This looks kind of crappy though when there's no sort of this layout isn't very nice. So what I was thinking, like one thing that we would do today is figure out, okay, each of these inline collections, as they're called. An inline collection is like a run of texts and images like this. So here we have like four images, then we have some text. Here we have 2 images, then we have some text. All of these like start with these input symbols, and then they have the text. So if we assume that is going to be the case, same thing here with these gamepad inputs, right? The number of images here might differ. Here we have 4, the WASD, and then you just have the one thumbstick thingy. But if we assume that, okay, we're gonna always start with like an image or 2, or 4, and then we have some text. What if we made it so that it would kind of calculate what is the furthest coordinate that the text will begin at? Here, for example, it would be this move crane arm. It is the one that starts like the furthest to the right. And if we go here, it is probably like the extend one down here, like for the gamepad, right? And then we would align all of the texts to that one. That might make it look a bit more nice. Let's see. I'm currently in the process of creating SDL3 GPU backend for Nuclear in my game engine. That's cool. Yeah, I've looked at Nuclear in the past. It looks pretty decent. I'm sure it can be a very good alternative. I went with NanoVG specifically because I want to use vector graphics for almost all of my UI. Not quite all of it, but almost all of it is vector graphics. Like all of this, for example, is vector graphics here. The text actually comes from it is like rasterized to a texture atlas. But all of the shapes are vector graphics, which is nice because then it becomes resolution independent. So if I just make the image smaller, all of it stays like very, very sharp, and if I make it super large, again it stays very sharp. So that's kind of nice, and it goes for all of these, of course, like all of these like larger graphics as well. Everything stays very sharp. These are obviously textures because these are actually like screenshots taken from the various sandbox levels that I have. Well, that's kind of cool. But yeah, nuclear is probably a pretty nice option or alternative as well. So right, we have that text alignment thingy. That's one thing that I was thinking I would probably do during this stream. And then there's another one which is just like this: the gripper trucks, gripper arm and truck bed. This should essentially be just like a matter of figuring out those lines and adding them, and then we will have that working as well. So this has like two different modes. One is a mode where you can control the truck bed like this. You can open it and close it. You can raise it and lower it, and you can reset it. And then you have the gripper arm like this, and actually one kind of detail that I've been thinking I might want to add is if we add some dynamic objects in here. Load dynamic objects, there we go. And just get a whole bunch of dynamic objects spawned. You can actually lift these guys up with the gripper claw, gripper arm. Let's take these larger ones. I think they're probably easier to grip. Even here in this driver mode, you can actually just press down on the left thumbstick like this. If you press again, it will load these things actually into the back of the vehicle. So this is something that I call a quick action. And I'm wondering if I should actually have that as well as a HUD input prompt or hint. You can do this. The problem here is that like this is highly dependent on the vehicle that you have going, and so the input system would somehow need to know about the vehicle types, which it currently kind of doesn't. So we'll see. Maybe we'll figure something out for that as well. And you can just grab a whole bunch of objects like this and load them without changing into the other modes at all. It's not very good for actually loading this sort of thing. For this, you actually kind of want the gravity crane. That's why the mother vehicle has the gravity crane. I switch to the gravity crane, and now we get nice inputs for this. So toggle active crane is A. Toggle it on. We can just slurp all of these up like a proper slurpee, and then drop them into this guy, for example. Bloops. There we go. Now we can drive away. It's always fun. But yeah, input prompts for the gripper arm as well as the truck bed. I think that would make sense to do in this stream as well. It shouldn't be super hard, super difficult to do. I kind of just one reason why I'm doing this right now is that not even I myself remember what inputs are mapped to what function or which function a lot of the time. So I actually just need to go and look at that quite often to remember what is what. So let's do that. Here in the README for Pre-Alpha 2, you can, by the way, if you're new here and you haven't really familiarized yourself with the project, you can actually play Pre-Alpha 2 today. It's a pretty old build. There's a new one coming relatively soon, but you can play this today if you want to. Do join the Discord, where you can find the download link for Pre-Alpha 2 on the announcement channel there. But here we have the controls, and I'm needed to like set up this sort of like table, just because there hasn't really been any hints, right, about what to actually do with it. There's been like 1 or 2 maybe in the game. But here we have the cargo crane controls. In Pre-Alpha 2 there's no gravity crane, so there's only the cargo crane here. But we have the gripper arm and we have the cargo bed for the gripper truck. So these things, right? We need to map these to the... I'll essentially create inputs for these. And some explanation about what they do. And then we'll see them in the HUD. And that shouldn't be super difficult. So let's actually just start with the gripper arm. What do we have? We have the triggers, left and right trigger, and on the keyboard it's S and W currently. Really not sure about these inputs, by the way. They can be kind of wonky, but if we create this now and then I change them later, they will get automatically updated in the HUD. So that's really nice. But yeah. We have the rotating of the arm, which is left trigger, right trigger, and SW. So here we have a sort of like a nice mapping between, okay, we have one thing on the gamepad which maps to one thing on the keyboard, and the same thing here, actually for all of these, just 1-to-1. Like here, for example, cargo crane controls is like moving the crane arm, is left thumbstick, so that's 1 to actually 4 different keys. So that was a bit hairier to actually set up. Here we have a nice 1-to-1 relationship to everything, and I think everything with the cargo bed as well. So with a little bit of luck, this will be super easy. Let's see. I'm gonna move this out of the way so that I can see it, but you don't necessarily need to see it because I will do some wonderful work in Excel here for a little bit. Hey Zidla1, welcome to the stream. Right, let's see. So this is my localization sheet. Here we have English. All of the texts, all the localized texts in the game are in this column. You can see that we don't have like a whole lot of text yet, but we have some. Actually, we have a whole lot more than this. This is some like really old, localized text. There's a whole bunch of text actually in the demo mission, which can't be found here. It needs to be localized, but it isn't, so it's only in English. But anyway, here we have columns for a bunch of different languages, and then Swedish as a sort of test, just because I don't know any of these other languages, so I just needed something so that I could actually sort of like verify that the localization system is working. But here we have the input prompts for the cranes. We can add another row here, and if we add a hash sign here, or sharp, whatever that is called, that's sort of like a comment, so we can just write a comment here that these are the cranes, right? So this all gets read then by my script, which brings these into the game and actually like generates code based on this stuff. So here we can then have the gripper truck arm or whatever. Let's add a few more lines here because I know I'm gonna need a few more. I don't know exactly how many. Well, let's start with that. And right, so we have the rotating of the arm. Let's do text UI input prompt. That's not how you do it. Text UI input prompt rotate gripper arm. That would be one thing that we want like actual different text for. We have the text UI input prompt close gripper fingers. And actually maybe we can put those on the same because it's like open and close. So let's do open close, right? And then we have the resetting of the input prompt reset gripper arm, not crane arm. Right. So 3 things. A few of these will have 2 actual symbols, so you can rotate forward and backward, right? And you can open and close, and then one of them has just like the 1. So here we can see like we have these double squigglies. If we go into the game and look at one which is like has just a single symbol on it. So let's do cargo crane. Right, so we have reset crane arm here. It's R on the keyboard, and then it's Y on the gamepad. So if I press the Y button on the gamepad, it just like resets itself here. So we have 1 symbol, and then we have a little bit of text. We can see the same thing here in Excel. Is this reset crane arm? So we have double squiggly crane reset pose, and then ending double squigglies. This is what is called an input ID. And the input ID is what the gameplay code actually reads. It doesn't care whether that is bound to the gamepad or the keyboard or the mouse or, I don't know, like a head-mounted display, whatever. It's just an input ID. And then it's up to the input system to like map that to different things. And we have, like I mentioned previously, we can't really rebind keys in the game yet because I don't have a menu for doing that, and I don't have a system which like reads and saves that to files. But the system is actually already set up, and if we go into, is it input maybe? No, oh, here we go. Input mappings. Yes. Input mappings. We can see that we are mapping a whole bunch of you know, gamepad buttons, keyboards, even mouse for some things, and these are mapped to input IDs. So here we have, for example, crane forward backward. There's crane forward backward in these double squigglies again. So like these kind of things. This is just an enum in the Zig code. And we can see that, okay, we have gripper arm. Gripper arm vertical rotation. Okay, right. So this is probably actually a little bit of a historical crap being still in the game from when I had the old, like this is the new gripper vehicle, right? This truck, which some of you may have seen. We had a previous one, just this thing, this hideous thing. This thing actually has a gripper arm as well, which can kind of rotate like this, and then it can sort of, how did this work actually? It can move, I don't even remember how it, maybe I've broken the thing. It was able to kind of move this piece like back and forth, and then it can also open and close the claw just like this. But yeah, this is a pretty universally hated vehicle. Like both me and my testers kind of don't really like this thing at all, so I made this thing instead, which is just like much easier to actually do things with, and also much more fun to play with. But let's see, where is that's the truck bed, gripper arm controls. Right, we only have the vertical rotation. We don't have the horizontal move back and forward. That's why it actually didn't work. Yeah, so there's a comment here that these are not really used, but this is the input ID that we're interested in. Then we have open and close fingers. That's another one that we are interested in. And then the reset pose. And then we have the quick action, which is, yeah, maybe we can actually put that. That would be some sort of like quick load sort of thing. Let's do maybe like text UI input prompt gripper arm input gripper arm quick action. and then we can call it in the game whatever we want, which I think is going to be something like quick load or something like that, right? Grip and load or whatever. But let's start with this. So we had two input IDs that we wanna map here. That's one. Then we have the other one. So rotating forward and backward. This would be rotate gripper arm, right? And then we have the open and close. That's also two different input IDs. So again, we're gonna do this and that. And then we're gonna take the other one, close fingers. So open / close gripper fingers. And then we have reset gripper arm is just one, so that's what that one. Reset gripper arm. Gripper arm reset pose is the name of it. Reset gripper arm to its default pose, right? And then we have the quick action, which is this grabbing of things. So I think it's currently like if you press down on the left thumbstick. I'm just gonna call this quick action. Let's call it like, I don't know, grab and load, whatever. I don't know. I don't exactly know what that's gonna be called. We have these four now. So the way Excel works means that no one can read or write this while it's open, so we're gonna have to close it. I'm gonna find my batch file here. So here's the actual file that we just looked at. And there's a batch file. When I run this thing, it generates a whole bunch of stuff for me. Among other things, it generates like localization keys. So here we can see a whole bunch of new things that I've added. Some of these I haven't actually submitted, even though I did them previously. But we can see that our new things are like down there. So rotate gripper arm, open and close gripper fingers, reset gripper arm, and gripper arm quick action. And this is like a generated file of all of the items. And there's some hashes and text versions of it as well if you need that. So with this, that means that especially if we restart the Zig language server, because it sometimes takes a little while for it to realize that something has changed, right? So gameplay input manager. This is a place that I spoke about in the last stream, and this is now the system that manages these like lists of things that we want to show input prompts for. And in here I have a new function called register HUD input prompts. There's some commented stuff we can take away. So it's a place for like the driving mode. I don't exactly know what to do in that one yet, but it's there if we want it. We have one for cargo crane controls. We have one from gravity crane controls. Here we have gripper arm controls. It's just a to-do comment here because I haven't actually added anything yet. So here's where we can actually add these now. And you can see here that these actually go into this file that we just updated from that script. So we can refer to these lines that we put into Excel. We can refer to them from Zig now, which is pretty nice, because then you get like actual like auto completion and everything. So only in input mode. We don't need anything like that for this, because we had, like I said, we had just like a one-to-one mapping between gamepad and mouse and keyboard. So we can just use the same ones on both modes. So gripper arm, what was the first one? It was rotate gripper arm. And the order here that you actually add these in is the order that they're gonna appear in the UI. So it makes sense to have a little bit of a think about that maybe. Reset gripper arm, and then we have the quick action right there. All right. With a little bit of luck, That's all we need to do. Now we just need to build this. And with a little bit of luck, that's all we need to do to actually see them for the gripper arm controls. And then we have the truck bed control there. Oh, yeah, we're running the game, so we can't build it. There we go. Let's see what's what. So, gripper arm, look at that. Oh, the grab and load icon has some issues, clearly. That's not how it's supposed to look. It's supposed to look like this. There's something funky going on. Like it is the correct icon, but it's not getting. Yeah, that probably has something to do with well, I don't know exactly what it has to do with. Something with like importing the data, probably, right? Anyway, if you press down on the left thumbstick, it actually does this sort of thing where it tries to find something. So if we spawn like an object here, let's do like a crate number 2. If we just press down on it, it actually kind of like lifts it into the air like this, and then you can continue messing with it. Or if you want to just load it automatically, you can just click it again and it will load it for you, and then just drop it off. So anyway, that's cool. So here we can see now that, okay, left trigger, right trigger, X and B. And I wonder if it should be the other way around, so it would be like close and open. And A and D, yeah. So the way I've done this is that like if you have A and D in that order, then you have open / close in that order as well, so you can sort of map one to the other. But I think it should probably be the other way around. So we have, because you're sort of starting with the open one, right? And then the first thing that you'll want to do is close it, and then you open it later on. So it kind of makes sense that it would be in that order. Close. Something like that. Whoa. Didn't like it that I did this updating while it was running, apparently. For some reason. Yeah, I don't really need to rebuild it. It's only data changes when you make stuff like that. That sort of change. So now it's X and then B is opening. I think that makes sense. Yeah, that makes sense. And then Y is resetting. Okay, cool. Well, this worked out except for this icon here, this grab and load icon. Wonder what's up with that. It's probably something to do with how I've exported, you know, this shape here from Affinity Design. But I don't think I'm really gonna have to. I don't think I want to actually debug that on stream. Probably just some super weird thing. Affinity Design's SVG export is not really what it should be, unfortunately. Anyway, let's move on to the next one, and then we can look at that layout thing that I spoke about. So the next one would be the cargo bed. So let's go back to here and add. We have basically 3 lines here. So if this is again like a comment here, gripper, truck, and bed, and we want at least 2 more lines, like so. Text UI, input, prompt. Let's just add this a few times here, like this. And then this would be raise and lower, right? Lower, gripper, or maybe just like truck bed. The next one is open, close truck bed hatch. And then this would be reset truck bed. Right. Let's look at the input IDs for that. So if we go here to input mappings, truck bed is even simpler. We have bed raise and we have bed lower. Okay, so let's get that. Oops. And lower. Something like that, and then we have hatches. Open. Close hatches. And then reset pose. Yeah. Reset truck bed. Something like that. That will get us started. Again, I need to shut that down, otherwise the script will tell me that I can't read the file. It's a little annoying, to be honest. Race. Look at that. ZLS even figured it out without restarting it. Open, close truck bed hatch, and reset truck bed. There we go. So let's see if this works. Right trigger, left trigger, X, B, and Y. Same thing with this. We have shift and we have control. And we have R. Okay. That's not bad. It's not bad. Yeah, grab and load. I don't know, does grab and load... Yeah, grab and load does nothing here in this mode, but it does work in the gripper arm mode. And it also does work in the driver mode. So we would ideally want to have that thing there as well. Yeah. That would be kind of nice, I guess. But I don't know how much input information we wanna plaster on the screen here in this normal driving mode. Like, it might be a little maybe annoying if you have like a whole lot of this stuff on the screen all the time. Some of it might be pretty good to have, just to make it a bit more obvious that you can actually do these things, like drive up to something and grab it just by pressing the down on the thumbstick there. Yeah, we're like lifting the entire vehicle off the ground when it is doing this maneuver, which is pretty fun, I guess. Yeah, I think we have the most important to have input texts on the screen now. That's nice. I need to fix this issue with the grab and load icon not looking correct, and then I need to look at that layouting thing. So just like moving these texts so that they all start at the same level. So let's maybe do that next. Not exactly sure how to do it, but I think we can probably figure it out. Oh yeah, and we have this thing which actually, this is again from last time. Select the correct background based on the number of prompts in the list. I mean, we could do that if we wanted to. I will just hard-codingly drawing this medium one. We have the small one and then we have the large one. So my thinking was that like if we had, you know, if we have it's G prompts items, length is larger than or maybe equal to or larger than 8. Then we draw the large one. If it's not, let me check if it's if it's equal to or larger than, maybe if it's larger than 4, just equal to or larger than 5 in other words. And then I think we're actually checking. Yeah, we can just do it like this. Prompt count. So we need to check it here everywhere. So let's just put it into a const, and we can check it like this. You'll notice that the code quality here is a little bit of repetition. I can't be arsed really to do anything about it. I'm just trying to keep it as simple as possible so that I can realize when I look at this a year from now. It's just immediately obvious what is going on here. Really not trying to be fancy or anything. Yeah, I don't know if these like numbers here are good. We're gonna have to figure that out as well. But now if we go into this, we have the this is 5, so we get the medium one. If we go here, this is now the small one. I don't think we have any with the really large one. Maybe we can bring this down a little bit more. So let's do that. 4. That can maybe be like 7. Just lower them by 1. Both of them. So now let's have a look. So this would be the medium one. And now you can see it like changing. I'm not actually 100% sure that's a very nice nice visual. But it kind of works. Hey Seb, welcome back. Still on the HUD business. Right, so this is a little stupid. We have like LT and RT, and then we have RT and LT. That is maybe a little stupid. Yeah, I think we should change the rotate gripper arm to be the other way around as well. So RT is first, yeah, for sure. Let's do that. So this, like this setup here, LT-RT, that is wonky. That's wonky. Let's flip it the other way around. So that would be this one. Hopefully I did it the right way now. I think that is what I wanted. I think that is what I wanted. Let's see if it actually... Yeah, this looks better. So you have RT first, because RT is sort of like, you know, typically what you will be using to actually make the action happen, such as you know, raising the bed, as opposed to lowering it. Lowering it is basically like undoing. And then RT here as well is like raising this arm. So that looks better. And then also, if we go here, we go to the... Here again we have RT and LT is moving the crane up and down like this. So it's like the same order of these actions. Probably just makes sense that way. Yeah. Okay. Pretty cool stuff. I'm just very much in like get stuff done mode currently. Whoop. So that I can get a nice pre-alpha 3 out for you in about a month or so. This is one thing that I've just been thinking about for probably a year now, that I need these HUD input texts here to give some guidance on how to use these things. So that's nice. Okay, let's figure out the layout now. To have those texts start at the same x coordinate. So the rendering here is kind of custom in the sense we don't have like any like UI widgets or anything like that for rendering these runs of images and texts called inline collections. You can see that the input prompt type here, the struct, it has an inline collection. The inline collection is essentially an array of text inline objects. It can be an image, and if it is an image, we have the pointer to that image here. It can also not be an image, in which case it is text. And we have scale and we have width. And yeah, there's some other metadata there. And then when we build the text inline collection, it basically like figures out, okay, which of these like parts are images, which of them are text. And we do it here in the render function. There's a for loop for iterating over all the prompts. And then we have just a boolean here, needs rebuild, that we can set. So for example, if the UI language changes, we need to rebuild these things. And then we do build text inline collection, and then we set it back to false. And then we do the actual rendering. So we render the text shadows first, and then we iterate over. Yeah, we have a bunch of for loops here. Here we're iterating over all the object items. So this is like it's an array list of these text inline objects. So we render the shadows just to make the text a bit more readable against like light backgrounds. And then when we render the shadows, we render the whole thing again. And then at this point we do, okay, is this an image? Then we render the image. If it's not, if it's a text, then we render the text. That's how it works. And so we basically need to know the text x coordinate right here and also right here. Those are going to be the coordinates that we need to actually change and figure out sort of before we even start rendering anything. We need to figure out, okay, at which point are we gonna start rendering text. So maybe maybe we do like a completely different. I'm gonna copy this for loop here, and then we do this thing sort of like ahead of time. So before we render anything, we figure out, okay, what is going to be rebuilt, right? And I think we can do all of this outside of the for loop. Just set everything up here. Right. I don't know why it doesn't get rid of that. Do we use I for anything? Yeah, not necessarily. I'm just gonna take that away as well. Oh, oh, right, okay. This guy needs to go into the thing. There we go. That's probably why it didn't give me an error, because it was confused about the previous error. Let's make sure this actually works before doing anything else. So now we just like we set the align and font size before we do anything else. I don't really see anything that would like break that here. I don't know why we essentially needed to do it every time. Fill color and font blur. Yeah, these things need to actually be set, I think. Yeah, because fill color is like black with a quite little alpha. So this is the shadow color, and then the font blur obviously is what turns it into like a shadow, a blurry shadow. Then we reset the thing here. So we need to set that, and then we need to do the fill color. So those things are fine. Let's keep them there. But the text alignment and the font size, they don't change across the, you know, entire rest of the rendering. So no need to set those. Cool. Yeah. Let's make sure this builds. Yes, it does. And then we run it, and we need to make sure that we haven't broken anything. All right. Looks pretty good. So now to figure out that, okay, we have WASD here. This is the longest run of images. The text starts at this coordinate. So we need to run through all of these lines before we render them and figure out, okay, what is the first or the furthest? What's the furthest text coordinate that we have, and then we just render all of these lines with that coordinate, and then we have them nicely lined up. I think that will look better. We'll see. So how do we do that then? Well, there's a bit of stuff going on here. Let's see. So we have a start text X, which is like pixel pos. So that's the entire widget's pixel position plus size times 6% essentially. That is the start text X, and we actually reset that to here as well. So we should probably have a start text X which is shared among all of these guys, right? And we need to calculate it here in this for loop so that this for loop can use it. That makes sense. Yeah, and here we can see that, okay, we're iterating over all of the prompts, and we're calculating where the text should start. So we have the text which is set to the start text X, and we take its width times its scale and add it to it. So I think we should do the same thing here. So let's have a start text X probably outside of that. Let's do like a shared start text X. That would be an F32. Now we can do it like this maybe. We can just deduce the type from it since we make it a variable. And then we run through the inlines for each prompt, like here, after we've rebuilt it, you know, if necessary. We run through the inlines. We don't render anything, so we take that away. We take this shared start text X and add it. But actually, we want like the last texts, like the highest coordinate essentially, at which point we render an inline, whether that's text or an image. That is like the simplest version. So let's start with that. So let's do var text X, and it's initialized to that. And then after this thing, actually, let's not do that. Let's do this. That comes there. I'm sorry if this is confusing. I'm kind of figuring this out as I go. That now needs to be probably specified to be an F32. So start text X is the same as before. We assign that to text X, and then we add it. So we figure out how long it's going to be, and then here is like the shared start text X is the maximum of itself and text X. Right? Does that make sense? I think it makes sense. Take that away. So now it also takes those images into account, which it needs to do to kind of like offset it properly. Then we get the largest of those. That's where the text needs to start. And then here, we don't need that one. We don't need that one. And we don't need that one. And here we can just use that. And again, here we can use that. Or that. No, actually, that needs to happen. Okay, yeah, so we're gonna... Yeah, this is kind of stupid because image X is like text X plus. So that this should actually not be called text X. It should be called probably something like inline X. But we're just going to use the shared start text X with the texts and let the image do its previous thing. Oh, what happened? So let's see what this does. Okay, so now we have them all on the same level for sure, but it looks like I messed up the start there somehow. Let's see. So pixel plus pixel size, that's that, and then we plus it. I think that should be right, but it clearly isn't. Right, like if we start with this, if we use this instead, then the text would be, they would start from where the first image starts, right? That's how it would look, I think. Yeah, so now they start where the images start. Okay, and what we do to this guy is that we take the start text X, we plus all of those to it, and then we get the max. Hey Bruno, welcome to the stream. The stream where I make math mistakes. Clearly. Should start text X. That's a variable. It hasn't actually gone out of scope or anything. That obviously wouldn't compile. Let's print the thing. Print the thing and see what we get. Like when this kind of preparatory, not that, but base is print F. When this preparatory step is done, let's do like two decimal places, because it's going to be in normalized UI coordinates. I'm pretty sure. Oh, we have the game running. Yep. Right. So, what is the thing? It is 0. Okay. So that means that we're doing something wrong here. Okay. Let's do a little bit of an information overload here and actually print this, right? I mean, if you're spotting my mistake, don't be afraid to just shout it out in the chat there. So start with this. Actually, we should probably print that as well, but we already actually saw that it is not 0. This is 0. And then we have text X, which gets assigned to this start value. And then we bump it with that. And then we get the max. Yeah, that should be fine. That should be fun. Oh, is there some sort of actual logic error here? Right, okay. Yeah, okay. It's probably quite obvious. Yeah, so see, I'm just stupid is what I am. We can't put it inside that one because that only runs when the thing needs to be rebuilt. It needs to be outside of this if statement here. Good job, good job. So now we should get something much more sensible. So it wasn't actually a math mistake this time around. It was, I make every kind of mistake on this show. All right. Now we probably have a math mistake though. Yeah, I think the issue here now is that we want to essentially do like if object is image right there, like that, because otherwise we're gonna end up where the text will end. I'm gonna have to like probably do some checks here to make sure that we're not if we're printing like a run that has like images and texts and more images and more text, then it just prints it normally like we did before. But yeah, now that is what I was looking for. I'm not sure that is the most beautiful layout I've ever seen, but now you can see that okay, now it kind of like figures out the position to start printing the text so that everything kind of fits. And we can also already see that okay, we're gonna need a little bit more margin there on the right side of those symbols for sure. But actually I don't hate that. I don't hate it. So we can just do, you know, plus equals 0.03 or something. This is normalized coordinates again, so it will work with all resolutions and everything. We're not working with pixels here. Well, we kind of are, because this is... Oh, actually this is... Oh, never mind. This is actually pixels. Yeah, pixel pos. Yeah, this is pixels. We've gone from... yeah, these are the normalized coordinates. Okay. Good thing I realized that. So we're gonna actually want to have something like, you know, pixel size x 0.03. No F in Zig. So we always get the same sort of relative distance depending or regardless of the resolution. Something like that. Yeah, let's see. Yeah, and that's way too much, but the idea is correct. Let's just bring it down by maybe just something like that. Quite little. Let's add a comment here. Add a bit more margin to the right of the symbols. Yeah. Even that may be a little too much. But starting to get there. And if we switch between this it's a little too much still. These like normalized coordinates get like really tiny. And then we need to verify that actually it works with smaller and larger resolutions as well, which we can just do by resizing the window. So let's see. Yeah, okay, that looks better. Now one might argue that like maybe these symbols should be actually centered now rather than right aligned, but you know, let's start with this. Yep, that's pretty alright. Looks pretty alright. We can do the window, set the window back to set size 1080. Get it back to the original size. There we go. Yeah. I'm not 100% sure about that gradient background there, but I don't know. Maybe we can actually play the demo mission a little bit with this and see what it looks like. I think it looks pretty alright here when we are looking at like things down on the ground, but then when you're looking at up to the sky, it's kind of obvious that it's a linear gradient. So what I could do is I could have the gradient in a texture and then render that thing with the texture as the sort of paint, as NanoVG calls it. That's one way to achieve a non-linear gradient. NanoVG only supports linear gradients. Sure. We can start the game here and play a little bit. So this is the mission that you can play today if you want to. It's an older build than this. I say this in every stream. Still, I like to advertise that you can actually play this mission today. In the build from the summer, and this is what we've been calling the demo mission. And if you want to do that, all you need to do is join the Discord, and you can download the build from there. So let's actually play this now. Where do we want to go? Do we want to go into the base or do we want to go to the refinery? The refinery has us actually playing with the crane immediately, so let's do that. Let's go to the refinery. I haven't actually done that in a while. I can tell Mother to actually not go there. Come here instead. So we can use the crane to actually lift this fallen smokestack off the ramp so that we can get in. Because if we try to just drive in here, we'll realize pretty quickly that can't get past this thing. Not with this vehicle. Bonk. And of course, there are like several different ways of actually solving this. You can just lift the scout over onto above the fallen smokestack with the crane if you want to, or you can just like remove the smokestack altogether, which I think is what we're gonna do now. I think that makes sense. So let's switch to this. I'm gonna want to actually turn this thing around so that we get closer to the pipe with the correct crane. Oh no. We're actually stuck here. Nah, we're fine. Yeah, the unstuckifier could have helped us get out of that trouble there, but I didn't need to use it. The unstuckifier also needs to get a proper HUD visual. So cargo crane, all right. We have all of the nice inputs there. Ain't that cool? You can read them against the sky pretty well. You can read them against darker things even easier. And now we can see, okay, extend the cable, that's X. Let's do that. And then toggle the magnet is A, then move it off to the side, like so. And it's actually kind of heavy, So it just rocks the entire vehicle. Every which way. Yeah, you can cause some pretty extreme physics forces to happen here if you aren't careful. Let's give it a bit more cable here. The scout is a little bit in the way. They're right in the middle of everything. Can't be helped. Let's just lower this down to the ground. That's good. And it comes rolling down the hill, of course. And then we can do reset, which is Y, and it does the resetting even though we've actually already switched to the other one. Oh, we're stuck. Can drive under the whole thing. And the crate is nicely resetting itself. That's cool. Okay. So this way we can get into the refinery using the monorail. That's fun. And here we can see that actually we do have some other let's release the mouse there. We do have some other input prompts here. These are the so-called interaction prompts. So when you come across something in the world that you can interact with, such as another vehicle or one of these interaction areas like this, you get an interaction prompt. So that's separate from the input prompts that we worked on today, because those are not dependent typically on what you have in the world, but rather on your vehicle and sort of like the mode or the functionality of the vehicle that you are currently using. But it might actually make sense to like look at those two together and make sure that they kind of fit together nicely on the HUD. I think currently they're a little different, like the interaction prompts are a little larger than the vehicle prompts, for example. Alright, so now we're inside the base. But we can't ask the mother to come to us. She says, I don't think I can get over there. You actually get a like a HUD debug text here as well. No path to target. Which makes sense because the gate is closed. Alright, power station. Yeah, well, we can actually just take. I know for a fact that we're gonna need this vehicle. So here actually, if we drive closer to this, we have the switch vehicle. Yeah, you can't actually switch the vehicle while you're using the gripper arm. So here you can see the texts there in the HUD. Yeah, you can't actually see both of those at the same time. So it might not actually be super important to kind of unify those right now. Can you use the interaction area with this while you are in the gripper arm mode? I don't think you can. So here's press X to start monorail, but yeah, you can't actually. Pressing X now just uses the gripper arm. So okay, that's fine then. But it's kind of neat. It's starting to feel like a game now that we have these HUD things here, because it makes it more obvious what you can actually do in which mode. So I think that's pretty nice. We should definitely have the quick grab thing highlighted in the HUD with this vehicle though. Because now I can just, without changing any modes, I can just go grab that guy and actually load it. Oh, I don't want to load it. Let's move it back. Yeah, you can interrupt the loading of it if you don't want it to load. I don't want to load it anyway because I want to actually plug it into one of these receptacles over here. So, oh, I missed it. missed it by a little. There we go. Whoa, physics forces. Physics forces. And then this one, you're gonna have to actually switch to gripper arm mode. I'm gonna have to redesign this thing for this vehicle. It was designed for that previous vehicle that we looked at earlier in the stream. You need to like fiddle a little bit with the gripper arm to be able to actually grip anything here. Luckily we have the HUD, and we can load that guy into the back. Why not? Load it like a boss. There we go. Alright, so now the gate is open, which means that we can ask Mother, hey, come here. Come to us. And we just need to find a few more of these. I want the scout to come here as well. Why not? We need to find a few more power cells to be able to power up the elevator, which is over there. I haven't actually played through this demo mission in a while, so it's pretty good that I do that. Yeah, here's one. They're sort of randomly, semi-randomly spawned, these guys. So they're not in the same place every time. Sight of Mother yet. We can figure out where she is by just using the radio contact. There we go. Hello. You get that nice icon there that shows you where in the world your companions are, so you don't need to guess, which is nice. Plug, and then one more, right? The scout to get out of the way, otherwise he's going to be blocking the path to Mother. I'm just going to use this vehicle to go scout for some more. Hello. No vehicle sounds from Mother yet. Makes it a little lame, maybe. Definitely need some vehicle sounds. So sometimes there's a power cell here in this ruin of a house we have over here. Not always. Sometimes. We have a power cell in here. Nope. No power cell. Alright. There can be another power cell up there on that mountain path. Near that big green tree over there, but that thing is a bit tricky to get to with this vehicle, so let's go look for another one. You can get a power cell from the refinery, but you can also sometimes find one over this way. We just need one more. If there isn't one here, then we're gonna go to the refinery and get one from there. Yay, there's one. So here's this mysterious big door. And right in front of it, power cell. It's a bit tricky to get to that now. I managed to nudge it into a place where it's kind of tricky to get to. Let's see if we can move that other one out of the way, like so. at this. Here's the new tire model coming into use, where you can actually move things with your tires. Spoke in the previous stream about working on the new tire model, which is more precise than the old one. Now we can do things like nudge objects around. Rockstar TTV asks engine name and says hello. Well, hello to you. The engine is called Basis. It's my own engine. It's a self-made thing. And the game is written in Zig, but the engine is written in C++. So little sort of weird kind of hybrid thing, but something I went for because I wanted to use my engine. When I discovered Zig and was like, yeah, this is awesome, I want to use this language, I already had my engine, so I figured, yeah, let's see if I can just make it work with the Basis engine. Turns out it was possible. Alright, there we go. The elevator is powering up. Excellent. So now we can just drive our vehicles into the elevator. I can actually ask them to come here. Right, come on. Let's go. Same thing with the scout. Let's see if they can make their way here. Mother needs to make a few reverse turns there to actually reorient herself. Slowly but surely the driving AI is getting pretty good. It used to be kind of a hot mess at some point. It's actually pretty good these days. Sometimes it makes some stupid things, but not always. There we go. Start elevator. Yay, we played through the demo. Although there are a few different ways you can play through this demo, but play through it one way. And there we go. I can still play when the screen is fading to black, which is maybe a little stupid. Okay, well, that worked out pretty alright. I had some thoughts about some changes that I figured I need to make while playing that. Now, of course, I kind of forgot them. Let's see, I'm waiting for this game and would like to ask one thing. When you publish it on Steam, please add the Steam Cloud feature. Do you mean the thing which makes your saves sync from one device to another? Is that the one you ask? If that is indeed what you're asking for, then yes, the plan is to have that as a feature. Absolutely. Whoa. But if that isn't what you're asking for, then do let me know. But yeah, Steam Cloud, I think it's called like Steam Cloud Sync actually. It's very handy indeed, absolutely. Get another vehicle to fit through the tunnel. The mother doesn't fit through this tunnel. Come on. Closer. Come closer, boy. There we go. Yeah, we can actually find a grip truck here. Let's go. Actually, yeah. Can maybe stop it where we find it. Stop. Stop. That's close enough. Let's go drive over to those boxes we have there. Yeah, so you can sort of combine these different modes. You can do things like this where you like manually pick up one of these boxes, and then if you're like, okay, now I want it loaded, you just click the quick action button and it loads it. Or you can do it the other way around. You can like start by using the quick action to pick something up, and then while it is actually doing it, you can like take over and then move it somewhere. Like this, and then put it down gently, or somewhat gently. Yeah, you can cause some real havoc with this if you're a bit uncareful. Like you can just lift up the entire vehicle with this. It's like super powerful, this motor driving this arm. I think you can probably pick up that entire thing. Let's see. I couldn't get a hold of it though. Be a little tricky to get a hold of it, but sometimes it kind of registers it as being gripped, and then you can lift up the entire thing with boxes and everything. Let's see if we can do that. All right. Yep. There we go. So now we have it gripped. Might weigh too much. Yeah, we can actually move it around. It is pretty heavy though. As you can see from the rear wheels kind of lifting off the ground quite often. Oh no! Things just falling out. And yeah, get stuck with it even. And of course we can even load it into the back. Oh no! I got stuck. Yeah, as you can see, the motor is very powerful. It lifts up the entire vehicle if we're not careful. Can I grab this now? Grab it. Yep, I can. Okay, let's try to save this. Yanking it out of this building here. Like this. Let's go out in the open, but there's no obstacles in the way. Right, and now if we hold down that, it will let go of it. Now we can try to load it into the back. So I have to approach it from a slightly better angle though. like this, and then grab it. Yeah, there we go. Now we can perhaps load it into the back. There we go. It doesn't quite fit. I can even pull it like this. That doesn't matter. Bon, bon. Let's move it down into the quarry. Up, 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 up. And then we use the truck bed. Okay, so we have the inputs here. Raise, lower truck bed. Let's raise it. Maybe even open the hatches. And then now if we drive away, it should just nicely fall down. Reset truck bed. Isn't that nice? Right, so I think this layout is now working pretty nicely. You know, it's good enough, I would say, for the next play test. But this will now only work if, let's see, if we have you know, images and then we have text, right? So if we have, put something here, test text bug, because I am expecting there to be a bug. So let's do some text, and then we do one of these input truckbed reset post, doesn't matter, some other text, right? Something like that. And then we actually add that to one of our cranes, for example. So let's go to, where is it? It's here. Let's go to this one, cargo crane, and do add p.add null test text bug, and then we rebuild this. I'm assuming now that the text is going to be bugged. So yeah, look at that. So we have some truly broken layout there. So what I'm thinking is, okay, we're gonna want to detect if the line doesn't follow this convention of like first images or image and then a single text, right? And if it doesn't do that, then we will want to use the classical way, just rendering those one by one. So for the inline collections that contain one or more images followed by a single text, image objects, followed by a single text object, we calculate the shared x coordinate for all texts so that they all begin at the same position, right? for inline collections. Oh, that don't follow this convention, we render. Well, let's do inline collections that don't follow this convention. We render normally, right? And so that means that we, in this, will want to have some sort of probably like Boolean shared text x bool, right? Set this to false. False. Hey, Xluxy. Are you trying to rob me? Here I was just minding my own business and suddenly I get robbed by a highwayman. Right, so this boolean here will be set to true if let's figure it out here in this rebuilding. So like when we rebuilt the collection, when we figured out, or when we rebuilt the inline collection, that is when we figure out whether or not this should use the shared text x coordinate, right? So figure out if this inline collection adheres to the above convention, right? And we do that by, again, iterating over all of this, but this we only do if we actually need to rebuild it, so it's not like super tricky. And what we need to essentially figure out here is how many text objects we have. We should have one, and the index of that text object, which should be larger than 0. If both of those are true, that means that there needs to be at least one image first and then one text object. If those conditions are true, then we can do this magic aligning of texts on the screen, right? So how do we do that now then? Let's use like optional number of text objects would be an optional usize, which we initialize to null, and first text object index is also a usize, which we initialize to null, and then we do this weird Zig double for loop syntax, which iterates over the items and yields an object, and then we also get the index of that. So if object is not image, whoop. Oh, that actually, hey, yeah, maybe using optionals here aren't actually that good of an idea, because we can't like just plus equal something that is null. So yeah, we need to do it like this. Come on. Plus equals 1, and then this one I'm actually just gonna do. How many is that? That's 6. Let's do 8. I'm just gonna do, you know, an obviously stupid number here. First text object index right. That could actually have been an optional, but let's not use one optional and one not optional. So if this one is, no, actually we can just set it to that, right? Is I. Right? If we have multiple text objects, then this will be, you know, 1 or 2 or something like that, or higher. So we need this to be 1, and we need that to be we need that to be 1 as well, right? No, actually, no. No, it needs to be, okay, yeah, we need this to be 1, and we need this to be 1 or higher. So once we've cleared this for loop, the object, which is here, prompt dot shared text x is if number of text objects equals 1 and first text object index 1 is well 1 or higher. Actually, we can just do it like that, right? We don't need an ifs there. Right? Isn't that what we need? And then we could take that away. And here we do, you know, if prompt dot shared text x, then we do that, else we do text x, something like that. And we used it there as well. I think that should actually fix that bug, but let's see. I may be mistaken, and actually it's maybe a little bit of a stupid name. I don't know. Maybe not. Maybe it's actually a really good name. Yeah, so now we have these are nicely aligned because they all adhere to the standard. This guy is just hanging around. Cargo crane, it says question marks. It's probably because, yeah, truck bed reset post is not actually mapped to anything there, right? But if we use this instead, then we should get a nice little icon there for ourselves. So let's run this again. There should be no code changes, even though it does generate the code, but there should be no code changes because we only changed the text, right? Yeah, now we have the R there, same as this. Okay, yeah. Yep, I like this. This I like. Because you can have sort of like a list of things, and then you can have just an explanation or whatever there towards the bottom if you really want to. Pretty cool. Okay, thank you. Let's get rid of that weird line there. I should put in the Swedish text there at some point. I'm gonna do that now. Sort of like a semi-serious attempt at localizing this into Swedish. It's mostly just for testing that things work. Oh no. What do we have? Oh, I know what that is. Yeah, absolutely. See, now that we took that away, now we need to rebuild the game. This thing, test text bug, it's not even a thing anymore. See, we can go to this guy. We can't actually go to that guy because it's not there. So if we try to run this now, or build it rather, it will fail. absolutely, yeah. That makes perfect sense. Yeah. Okay, better. Okay, so now it would be kind of interesting to see, to like figure out why that icon is messed up. What is that about? So it's this guy here. Let's re-export it first of all. See what we have. Left thumb down. SVG. Yes, thank you very much. It's not that one, is it? Yeah, it's not. It's here. Left thumb down. Right, it looks like this. But for some reason, it doesn't render like that in the game. And I bet you that this is just super messy. It's just like a bunch of empty things here. That's not great. Thumb 1. I don't even know if these are, if any of these are like really needed for anything. Just get rid of them and see if that helps, but I bet it probably doesn't help. So there might be some sort of, yeah, it just looks the same. There might be some sort of incompatibility with something that Affinity does for its SVGs. All of the other ones render fine. So sometimes what happens is that Affinity decides to Inkscape, yeah. I thought I had it installed. Apparently I didn't. Sometimes what happens is that Affinity Design decides to rasterize something. Oh no, this is not what I wanted at all. Where's the Inkscape? Here's Inkscape. It's kind of annoying that you get these like, bullshit pages before you get the actual page. So what we can try... Oh no! Oh, Inkscape. That's not good. Releases. Where can I get? Can I download this thing from? Oh, here we go. Okay, now the website suddenly works as well. I don't know what happened. Yeah. Okay. What I've been trying to say here for 5 minutes is that sometimes Affinity Design decides to rasterize some things, even though it like technically shouldn't, and that can break my UI system's rendering of it pretty badly. That doesn't seem to be the case here though, because if that happens, then there will be base64 encoded like image data in here. See, there's no base64 here at all. There's just coordinates, which is what we want. None of this actually looks, really problematic or anything. And of course, I'm not rendering the SVG data. I'm converting the SVG data into my own format. But now, for some reason, kind of looks like it doesn't know how to draw that properly. So let's see what happens if I open it in Inkscape, which of course works directly with SVG data. And it takes forever to install it. I never used NanoVG. Does it render SVGs directly or do you rasterize onto an atlas? Right, I'll show you in a second. Because the answer might surprise you. No, the answer is just like a little more complex than yes or no. Right, and it gives me some parts of this, at least in Finnish, yeah. Which is like, no, please don't do that. Please don't do that. Let's have it in English. Right, that one, for example. Okay, can I need to restart it. I guess is what that means. Here we go. Okay. Where's my... Oh, where is it? Where did it go? It's not that one, is it? No. I lost my... Here we go. Controller prompts. And then let's just drag that in. Let's see. Include SVG image as editable objects. Yeah, that's fine. Alright, and it looks pretty good here as well. It's pretty good here as well. Now, if we export this, if we save this as... something, how do we actually... Selection, maybe. Yeah, there we go. This one. SVG. Plain SVG or Inkscape SVG? I don't know. I don't know. I don't know where I wanna... Which version I wanna use, but I wanna put it in this folder. It's not a PNG. I want it in... Let's do plain SVG. We can call it bitmap, it doesn't matter, it's fine. So we have bitmap SVG. If we open it up in Edge, yeah, whatever. Right, okay, now it's very Smurl. Smurl, but it's right there. Okay. And now this looks completely different. Width, height, view box. Yeah, I'm not actually, super good. SVG, so I don't actually know exactly how these things work. But clearly it has kind of like, it's in the middle of the page here. Clearly it has only like taken this thing and we can probably make it sort of like so that it kind of fills. Okay, this is perhaps what I want. Let's export that. Yeah, replace. Let's see. That's still very small here. Okay. So what I'm used to, and the only way that I've really used these things is to actually have it like this, where it kind of fills the whole screen. I think there's the view box concept, which is sort of like the viewport into the thing, right? And you want it to essentially like fill the whole screen. One thing that we could try here is I'm gonna save this now in case I break this thing. There might be some of these might not be like necessarily expanded strokes, but I think they kind of look like they are now that I mess with them. Yeah, they all look like expanded strokes. So I don't know exactly what is going on. Probably gonna have to mess with this a little bit. Anyway, I can answer the NanoVG question. So NanoVG doesn't render SVGs directly, because NanoVG is essentially like a canvas-like API. NanoVG.h looks like this, and the API to NanoVG looks like this, where you have a very standard, almost like OpenGL-esque state machine sort of thing. You have a context, you set a stroke color on the context, you begin a shape. Where's begin shape? NVG begin shape. Begin path. It's here. Then you move to, then you do line 2, Bezier 2, quad 2, arc 2, close the path. And you can, before that you can do stroke color, fill color, this sort of thing. Some special things with like miters and line caps and all of the basic things that you need to like draw shapes in vector form, and stroke widths, things like that. So there's all of that, and then it supports transforms and whatnot. So it doesn't know anything about SVG. It's just a drawing API. NanoVG does have a almost like a sister project though, called Nano SVG, made by the same guy, Mikko Mononen, and it is just as not actively maintained as NanoVG is. But it's also very sort of small and easy to use, and this is what I use to actually, parse SVG files. And the output of the parser is a list of cubic Bezier shapes. So if you want to use this, keep that in mind. It took me an embarrassingly long time to realize that yes, it actually only does cubic Bezier shapes. So if you have a box in your SVG data, a rectangle essentially, it still comes out of this as a cubic Bezier shape. So you can then look at that data and go like, nah, okay, I see that is actually a box, and then you just convert it into lines, right? So what I do is I have something called bin SVG, which is not SVG at all. It's just my made up format, and it has this thing called the goofy SVG converter. So you give this an SVG file, and it converts that SVG file. Let's see here. It can convert both animations and as well as single images. So a single image here, for example, is we do a little bit of pre-processing. Here's the Nano SVG API. You just tell it an SVG parse. You give it the data, a string essentially, and then it gives you out an image, and then we pass that image here to the convert SVG data, and then the source image has a bunch of shapes like this. So you just iterate over the shapes that it has, and it contains essentially some commands, right? And I turn this into my own binary format, and that gets added into a bin SVG file. So if we look here at actually what we've been working on this entire time, this HUD input prompt list, you can see like the backgrounds, for example, are bin SVG files. And a bin SVG file is really like a small, almost like bytecode format. So we have some opcodes: begin path, stroke color, paint color, or stroke color, stroke paint, fill color, fill paint, and then move to Bezier 2 closest path, path winding. There's some miter stuff. Oh, I'm breaking things here. When you set up everything, you call either fill or stroke or both. And then yeah, the line 2 is here at the bottom because I actually added this relatively recently when I realized that, oh, actually all my lines are like Bezier curves unnecessarily. And then when you actually render this thing, out of it you create an SVG image, which again is not really SVG, but I'm calling it SVG, and you render SVG data. So this is one of these things that we just looked at. The SVG data comes in, and it's in my custom binary format. And then we have just a big for loop with a bunch of well, with an if statement and a bunch of cases. So very basic sort of bytecode interpreter almost. Not quite, but almost. And here we actually convert these into NVG calls, right? So now we're talking directly to NVG, as we have like move to, for example, close path, path winding, miter limit. So everything is vector. However, if you've ever looked at NanoVG, the library, you can see that it actually contains something called font stash. And font stash is another one of Mikko Mononen's libraries, which this actually renders fonts to an atlas. So there are some atlasing going on as well. Font stash in turn uses STB true type. I don't think STB image is actually used for the basic things, but maybe it is. But STB true type is actually used by font stash, which is then in turn used by NanoVG. So the font rendering in NanoVG is actually done using an atlas, but it all happens automatically for you. You don't need to like do anything for that to happen. So there's a little bit of everything going on in the back end. But yeah, the SVG rendering actually works surprisingly well. Like everything. For example, everything here in this intro animation, which you can watch if you just start the demo. Oh no, I broke something. What did I break? I think I accidentally touched my gamepad, and I think what happened here is that we have actually gotten a message about, yeah, input mode changed, and we have it here. The input mode changes during the intro. This was actually a really good catch. I didn't plan to at all. So we don't have any vehicle set currently, and that is probably, or that might be, why we get like bogus data out of this. So let's see, buffer 132. Count is 1, right? Yes. Actually, context count. Oh, it's 6. but I is 0. Alright, so we want an enum. This thing can't convert 132 into an input context. Interesting. Interesting. Yes. 132. Yeah, that makes sense because it starts from 32 and ends at 44. Ah. Oh. Right. I know what. It's this thing here. Yeah, it's that thing. This is actually a very specific thing. If we look at this, if we find this thing, this is something that I would probably never have found. You can see the input context here is cinematic controls. Cinematic controls is only enabled during a cutscene, and of course we're running a cutscene here. It just didn't really get started even. We're running a cutscene, and we're changing input mode. And yeah, the whole big list of input contexts just use, they deal with like integers. And so this is 132 because this first input context is 32 and we add 100 to it. So we have 132. But then we have the code here which tries to convert that into a means.input context ID right here. And means.input context ID, of course, doesn't have that. It runs from 32 to 44, so 132 is not actually valid. This thing crashes. I bet the error says something like that. Invalid enum value. That's interesting. Okay, okay. Well, yeah, what I was hoping to actually show you is, let's not touch the controller now because it will crash again. Like, this is all SVG data, which is actually animated using a program called Moho, which allows you to animate SVG data. And then I export it into individual SVG files per frame, and then my exporter can sort of like do a little bit of compressing, run length compression, essentially, to like get rid of duplicate frames and things like this. But this is all SVG data, and you know, flying through a logo like that can be kind of tricky if you don't do it with vector graphics, because like you're gonna need such an enormous texture, for example, to be able to do that. If you don't render it all in just skip that. If you don't render it all in vector form. Let's see. I was looking for ways to add simple icons to text. I'd heard some people use STB's TrueType to restaurant text to shapes on the CPU. Maybe use nano SVG to get the curves to pass to STBTT. Yeah. Yeah, maybe. That's interesting. That way I can put the icons in the same atlas I already use for font clips. That's an interesting thing. Like, you would essentially be creating like TrueType data on the fly from SVG, if I understand it correctly. Sounds very powerful to support SVG fully. Yeah, I mean, I really don't support SVG fully. Nano SVG only supports certain features of SVG, and so that already brings down the feature set quite a lot. And then Nano VG also supports just a tiny fraction of what SVG supports, right? So I support sort of like the intersection of those two. But yeah, gradients work, linear gradients work, specifically linear gradients with 2 stops, which is a little limiting sometimes, but sometimes you can just convert your 3-stop gradient into 2 2-stop gradients or something like that. That might work. And then radial gradients work. I actually use both of those in the intro animation. What's the rendering performance with NanoVG? Does it produce tons of draw calls, or is it okay? It could be better. It could be better. Let's see. If we do render stats, and we have a little over 1,000 now with this. It does produce quite a few draw calls, if I remember correctly. So if we do goofy dot render equals false, you can see that falls down to 50 and 869. So what is that? Yeah, it's like a couple hundred draw calls to render, you know, this and maybe something else that I don't remember right now. Now, yeah, this text up here, work in progress, I think is also, yeah, it's also NanoVG. But of course, like draw calls these days, like a draw call is not necessarily super expensive, especially if you're using D3D12 or Vulkan. Draw calls are in that sense cheaper than they used to be. I have worked on AAA games that have had draw call numbers in the like hundreds of thousands, even back in the D3D9 days, at least momentarily. They've had just like crazy amounts of draw calls. It's been just completely fine. I'm hovering here at about 1,000, plus minus a few hundred, I would assume, and it's just completely fine. I don't really. Well, I do think about it sometimes, but like I don't necessarily worry that much. NanoVG doesn't really come up in my profiler, except this one thing. Except this one thing which I talked about previously with the Bezier curves. So let me just show you what I did here. Let's see if I can remember where it is. It's probably here, isn't it? It's actually it's in the converter, but is it here maybe? Yep, here we go. All right, so here, this is the place we looked at previously. You get the source image out of Nano SVG. Source image or arrow shapes. You get the shape out of that, and a shape then has a number of paths, and the path has cubic Bezier points, right? That is what you get out of Nano SVG, nothing else. You don't get lines, you don't get rectangles, you get cubic Bezier points. And that I think that's a pretty good thing, actually, because that means that it can represent basically any shape that SVG can contain, right? And you can definitely represent a line using a cubic Bezier. That's not a problem. The problem, of course, is that when it renders cubic Beziers, it does it using something that it calls tessellation. I guess it probably is actual tessellation, but there's a function called tessellate Bezier inside of NanoVG. See if I remember the name correctly. Yeah, tessellate Bezier. This thing, and it has this level thing here where you can see that it goes up. It tessellates. It essentially like splits the curve in two, and then it tessellates one part, and then it tessellates the other part, and it goes to a certain number of levels. And here is an if level is above 10, then we return, which means that you do this kind of recursively 10 levels every time you tessellate a Bezier. And this thing, when I did my optimization pass for Traction Point earlier in the fall, I saw that okay, this tessellate Bezier actually comes up in my profiler quite a lot. What's going on there? And the reason for that, of course, is that everything is a Bezier curve. So even in my game where you have you have things like this shape here, which is a straight line, and there's a 45-degree angle and another straight line, and all of these are Bezier curves. And so that's a bit problematic. And then if we go to Nano SVG and we search for line, I think it was line. Yep, here we go. So line 2. Line 2 is of course like in a typical line algorithm, you don't have any more than this endpoint. You have X and you have Y, and you just issue a point. Okay, that's X and that's Y. But because everything is Bezier curves, it adds 2 more control points in between them. And what I realized here is that, oh, okay, a line, when Nano SVG adds the line data to, the shape, it always uses the derivative divided by 3, like this. So it's essentially like, if you have a line like this, a straight line like this, and the center point is about there, then like at a third of the way, which would be there would be 1 control point, and then 2/3 of the way would be another control point, right? And then this is the Bezier curve, which normally would look like this, and then you would have your control point there, like that, and there would be another control point there, something like that. So this is the format that Nano SVG always uses to add a line to the data. So what I did is I just detect that, right, like right here. Detect the straight line by looking at the control points. So you calculate the derivative or the delta. Delta, I guess, is not derivative really, it's delta. And then you check if it's close enough to a third, and in that case you just add a line to instead, and this got rid of like 95% of of all of those tessellate Bezier curves, because I just happen to have a lot of straight lines in my UI design. So yeah, I think I got rid of maybe like 1 millisecond of the frame time with that. Maybe not 1 millisecond, maybe half a millisecond, something like that. Let's say I'm even more curious to try the Nano SVG to SVG true type way. Could render SVGs on demand on the Atlas. Yeah, absolutely. For color fields, I could probably do it manually on the CPU too. They're using pixel from STP as a mask. Sounds too big to render on the CPU every frame, perhaps. I mean, if you're rendering it to a texture, then that's pretty big, right? My SVG data for that is actually like pretty huge. You know, like spatially huge. I can maybe show you if I remember where that file is. Let's see. Intro animation. Yeah, here we go. Okay. Right, so here's the thing. Burp. Here's the whole thing. Yeah, the madrigal animation is on a separate file. That's a separate thing. But here's the whole intro animation, and we can see that, you know, you have a few layers here. You have this topography, and you have the logo, and then this is the UI size, and when it starts to fade out, it needs to move these. These are just like hand animated. Actually, it's not a very good animation. I need to kind of redo this at some point. But when it starts to fade that centerpiece away, I just have a bunch of other boxes here that you can see. Like, if you consider this to be the screen, then this thing is actually like really huge. So not huge data wise, just like actual like spatially very large. And then I just move those boxes kind of like out of the way. And here is the point where it becomes, you know, less than fully opaque. So I just add those boxes in there. And all of this actually goes into the SVG data, but of course it doesn't really matter that you have like a huge, you know, quad like this outside of your screen. Doesn't really cost anything to me when I render it to the back buffer. But if you would be rendering this to a texture, maybe not. If you just clip the thing properly, maybe it doesn't really matter. I don't know. Yeah, I don't know. Might be just fine. Okay, so I have two issues here that I don't know how to solve. Well, this first one is perhaps solvable with a little bit of figuring out. So we have this function, which is actually only used in one place. It's not really that big of a deal. Yeah, so what I could do here is like, okay, this is, you give it a, you give it an enum, and that enum in this case is this guy. And you know, I think at least using Zig, you can figure out what's the first element or value in the enum, and what is the last value in enum, and then you get the int values from that, and then you check here in the, here we go, up there we go, and check here when you get back this buffer of U8s, is that value actually within the range, right? The animation is great too. Well, thank you. That's, I'm not a very good animator, but but yeah, I make do. So there's a handy function in the standard library, if I could only remember what it's called. It's something with... Is it maybe stud.enum? Yes, it is this thing. And this gives us... Right, okay. Yeah, I think we can fix it with this one, with a little bit of comp time programming here. So we give it, we have a type. This would be t values is stud enums values of t, and then we have const first t value. How do we do this? Yeah, I think we can do it like this. First t value, u8. We assume it's u8 because we use u8 here as well. Is int from enum t values 0, and we have last t value, which is of course t values dot len minus 1. Right. And then we need to check the thing here. So okay, let's do var valid count is 0, and valid count would be actually a usize, and then we return valid count, and then we do if buffer I is larger than or equal to first t value and buffer I is smaller than or equal to last value, then we add it to contexts valid count, right? And then we do valid count plus equals 1. Right? Wouldn't that work? I think that works. So we know we're gonna only want to have things that are in this enum type. At least it builds, so that's great. We're only interested in values in that enum type. So we get all the values. First value is that. Last value is that. Then we collect all the values which might contain values outside of this range into a 32 element long array, which I kind of hope we never have that many input contexts, but whatever. And that is context count. Then count is the minimum of whatever you gave in and the context count. Yeah. Exactly. And then this is a little crazy looking, so let's just do it like this. Int cast here, and then we can take away all these crazy conversions from that one. And then we count, okay, how many of those are valid? And they are valid if they are between this one and this one. In that case, we dare make this conversion. That should work. So now we should be able to freely switch between gamepad and oh no, this is gonna load directly into the level. No. Oh, stupid. Exit. Let's delete that guy. delete, yes, and then run it. Yes, we want to create a new game. So now I am with keyboard and mouse, and now I can switch between these two. Yeah, you can see things don't break. Yep, works. At least it works as if it actually does work when we test out the game. Let's see. Stop your moving. All right, now then. Yeah, and that does seem to work. I don't know. I kind of like this gradient thing behind those texts. As long as there's enough complexity going on in the background, I think it looks pretty nice. But then if there's not, then it looks pretty bad. I don't know. Maybe it's fine for now. It's probably fine for now. Let's spawn a gripper truck here and switch to that. Yeah. I think it's probably fine. It's probably fine, you guys. Let's move on to other things. Except I'm gonna want to debug this thing here, which I can't move. If I move my mouse, it goes away. But this icon not being what it's supposed to be, I'm gonna have to have a look and see what is actually going on with that. I need to make some other changes to my SVG converter anyway, to make sure that I detect the case we had in the last stream, where Affinity Design is without asking, just doing some adding some weird stuff to our data. That's not great. Currently my converter just like doesn't well do anything with that, but it should just fail at that point to let me know that there's some crap there in the data. So I'm probably gonna have to look at the icon there at the same time and see why that doesn't render. But hey, I think we have a pretty good set of UI prompts here now. Still hoping to wrap this today, actually. But we'll see, depending on how much time I have to spend on that SVG crap. Oh, I'm getting a phone call. 1 second. Right, sorry about that. I am needed elsewhere, but that's fine, because I was anyway thinking that this is probably a pretty good place for me to say thank you for today's stream, and thank you to everyone who came to hang out. I'm gonna have to go do some family business now, but I will continue working on this thing tonight, hopefully wrapping this HUD UI business, and we can move on to other, perhaps more exciting things tomorrow. If you want to play the game, do check out the Discord server. There is a link in the chat as well as in the description below. That lets you play Pre-Alpha 2, and it lets you play this particular level, mission. And Pre-Alpha 3 will be delivered as a Steam playtest. For that, you will also need to join the Discord server if you want to play that. That will be have just like a bunch of fixes and improvements to both the technical side and the game side and all of that. So that would be that. Do remember to like and subscribe. Go check out Traction Point on Steam. There is a link to that in the chat as well. There should be one in the description if I remember to put one there. Wishlist the game. It really helps out the project. And you know, do come hang out in Discord and just discuss the game and give feedback and all of that, if that sounds interesting. Anyway, that would be that. Thanks for today. Stay tuned for more videos and streams relatively soon. Alright, have an excellent rest of your day. See you next time.